Good afternoon, class. We are looking at Chapter 4, Application of Derivatives. Here's Section 4.6, Antiderivatives. Section 4.6, Antiderivatives. We have discussed various differentiation formulas from the basics, definition, product, quotient, uh, rule, rules also, the chain rule, uh, power rule, extended power rule, exponential rule, logarithmic rules, dy versus delta y, which is f of x plus delta x minus f of x, and dy is f prime of x dx. The concept of a linearization, which refers to finding the equation of a tangent line. 4.6, antiderivatives, antidifferentiation, also known as integration. Integral calculus has two parts. Differential calculus, which deals with instantaneous rate of change and slope of a tangent line. Integral calculus, which deals with accumulated change and area under a curve. Both parts rely heavily on the concept of a limit, and they are intimately related. Integral is the opposite of a derivative, also called antiderivative. The question is, given the derivative of a function, what is the original function? That's the concept. The antiderivative of lowercase f of x is the set of function capital F of x plus c such that the derivative of capital F of x plus c is the lowercase f of x. The constant c is called the constant of integration. Anti-differentiation is always called integration. When you differentiate a function, you get one unique solution. When you integrate, you get infinitely many answers. You get a family of functions because the derivative of any constant is 0. To indicate the derivative of x squared is x cubed over 3 or 1/3 x cubed plus c, we write it as follows with this notation, the integral sign, x squared dx equals x cubed over 3 plus c. This symbol, the symbol was introduced by Leibniz and is called an integral sign. It is an elongated s. Think about it, the s elongated, and was chosen because an integral is a limit of sums. In general, the integral of f of x dx is capital F of x plus c, and f of x, capital F of x plus c is the general form of the antiderivative of f of x. That's why it's also called indefinite integral, because it represents a family of functions, infinitely many different functions. If capital F and G are two antiderivatives of f, that means capital F prime as well as capital G prime, both of them are lowercase f of x, in which case the two functions differ by constant. So capital G is capital F plus C or vice versa. Doesn't matter. Their difference is some number. We're going to get a warm-up example. Determine these indefinite integrals. That is, find the antiderivative of each integrand. I look at the integral of 8 dx. Please understand this is a dummy variable, which is telling us what is the independent variable. Think of a function, you differentiate, you get 8. Clearly, the answer is 8x plus c. And in the beginning, when we learn something, we check the methodology of checking is to differentiate this, and the result must be 8. As you can see, that's the answer. Now, the importance of this is if we had, let's say, the integral of 8 dt, then the answer would be 8t plus c. If we had the integral of 8 d theta, the answer would be 8 theta plus a constant. So you want to pay attention to this and what it tells you, which tells you the independent variable. We've already done that. You basically Think of a function, you differentiate, it gives you x, 3x squared, which is x cubed plus a constant. And to check your work, differentiate the right side. You should get 3x squared without the dx, and you do. Please understand what we have here, everybody. What we have here is dy in essence, okay? That's what we have. So what is the integral of e to the power of x dx? What function you differentiate to get e to the power of x, and it's itself. So e to the power of x and a constant. Take the derivative of the right side, and that's the proof. The integral of 1 over x dx. Think about the function, you differentiate, and the result is 1 over x. That's natural log and a constant, of course. And we put it in an absolute value because of the limitation of a natural log when it comes to its domain, which is 0 to infinity. And so to check, all you have to do, differentiate the right side, and you get 1 over x. Basic integration formulas. What is the derivative of k times x, where k is a number, is a constant, is k? If that is the case, then what is the integration of the right side? That means what is the integration of a k dx is kx, and a constant, and c, of course, is also a constant. What is the derivative of x to the power of n? We're talking about the power rule. This is the power rule, everybody. N x to the power of n minus 1. So if I want to integrate x to the power of n, is the reverse process. So what do we do here? We multiply by n, and we take away 1 from the exponent. Now we are going to add 1 to the exponent, becomes n plus 1, and divide by it. So the integral of x to the power of n dx must be x to the power of n plus 1 over n plus 1 plus a constant, and n can't be negative 1 simply because the denominator can't be 0. To have an understanding of this, first I want you to understand when we differentiate this, if we were to verbalize it, number 1, multiply by n, number 2, subtract 1 from it, right? As far as the n is concerned, we mean the exponent. So the exponent becomes a multiplier coefficient, and the exponent goes down by 1. If I want to integrate, I go with the reverse process. Reverse process, everyone, means go this way. So 2 becomes 1. Instead of subtract, add 1 to n. You get n plus 1. Instead of multiply by n, divide by it, which is the n plus 1. And that's exactly what we get here. Of course, we can prove that if we differentiate this. All we have to do, class, this expression, we're going to call it capital F of x, 1 over n plus 1, x to the power of n plus 1, and a constant, and we're going to differentiate that, which gives you 1 over n plus 1 times n plus 1, x to the power of n plus 1 minus 1, and as you know, plus the derivative of a constant is 0. And I'm going to put it 0 on purpose. So what happens is, you still cancel each other, and we get x to the power of n. So that's a proof. We just got that, remember. We should get the integrand without the dx. So we just proved that's the answer, and also the concept of a reverse process. We're going to continue. Let me erase this work. We know this is the case, so let's go one by one. If the derivative of e to the power of x is e to the power of x, and we want to go this route, the integral of e to the power of x dx must be e to the power of x and a constant. If the derivative of natural log is 1 over x, and we want to go this route, the integral of 1 over x dx must be natural of absolute value of x and a constant. The only thing I want to add is, please remember this is the same as x to the power minus 1. In case you see it in this format or in this format, makes no difference. If the derivative of sine is cosine, then the integral of cosine x dx must be sine x and a constant. If the derivative of cosine is negative sine, then the integral of negative sine dx must be positive cosine x. So what about the integral of sine x dx? Then must be minus cosine x and a constant. Remember that. All you have to do, multiply both sides by negative sine. We also know the following. If the derivative of tangent is secant squared, then the integral of secant squared dx must be tan x and a constant. If the derivative of cotangent is negative cosecant squared, then the integral of negative cosecant squared dx must be positive cotangent x plus a constant. And the integral of cosecant squared dx must be negative cotangent x and a constant. The derivative of secant is secant tan. So the integral of secant x tan x dx must be secant x and a constant. The derivative of cosecant is minus cosecant cotangent. So the integral of cosecant cotangent must be minus cosecant x and a constant. Reverse process. When we differentiate or integrate, if we have a multiplier inside or outside the integral sign makes no difference. It will continue being a coefficient. Some are different rules. When we differentiate or integrate a bunch of terms, we do them term by term. That's the concept of a sum and difference rules. Just integrate or differentiate term by term. What is the derivative of e to the power of kx? Is itself times k. So if I want to integrate e to the power of kx, I get the same thing divided by k, because the integral of the right side is e to the power of kx. So if you put the k here, it gives you 1 over k. So the integral of e to the power of kx dx is 1 over k e to the power of kx and a constant. That with very simple examples using the power rule, the integral of x to the power of n dx. We know it's 1 over n plus 1 x to the power of n plus 1 and a constant. This one, the exponent is 7. We just add 1, becomes 8. So 1 over 8, x to the power of 8, and a constant. Now, do you have to do it in 2 steps? No. As long as you know what you're doing, either way is fine. What about the integral of x to the power of 99 dx? 99 add 1. So the new exponent is 99 plus 1. The denominator is 99 plus 1 and a constant, which makes it 1 over 100. X to the power of 100 and a constant. Very straightforward. What if we have square root of x? That's x to the power of 1/2. We differentiate or integrate makes no difference. The first step is to get it ready for the power rule. And now that it's ready for the power rule, 1 over n plus 1, 1 over 1/2 plus 1, x to the power of 1/2 plus 1, and a constant. 1/2 plus 1 is 3/2, and 1 over that is 2/3. So 2/3 x to the power of 3/2 plus a constant. The integral of 1 over x cubed dx. We rewrite it in a power rule format. So x to the power minus 3 dx, such that the power rule can work. So we are going to add 1 to the exponents, negative 3 plus 1, and also put that as a denominator. Negative 3 and 1 is negative 2. So 1 over negative 2 is negative 1/2, x to the power minus 2 and a constant. Take this down, make it positive. So negative 1 over 2x squared plus c is the final answer. Integral of e to the power of 4x dx. Remember, the derivative of e to the power of kx or the integral of e to the power of kx is itself. Now, in the case of a differentiation, multiply by k. Integration, divide by k. So the answer is itself. Divide by k, which is 4. So 1/4 e to the power of 4x plus a constant. What about the integral of e to the power minus 3x dx? K is negative 3. The answer is itself. Divide by negative 3. So negative 1/3 e to the power of minus 3x and a constant. Now, e to the power of x over 2 dx, if you recognize this as e to the power of 1/2 x, so be it. If you don't, rewrite it so you recognize k is 1/2. So 1 over k, that means 1 over 1/2 e to the power of 1/2 x and a constant. 1 over 1/2 is 2, everybody. So 2 e to the power of x over 2 plus a constant. We know the integral of 1 over x dx or x to the power of minus 1 dx is natural log and a constant. We may not recognize this. If we do, that's fine. If we don't, we rewrite it as 2 times 1 over x, which means 2 remains as a coefficient, or you can even put it out. We're just integrating 1 over x dx, which is a natural log, so 2 doesn't go away. 2 ln of absolute value of x plus a constant. What about the integral of 1 over 2x dx? The same thing. If you recognize what you have, so be it. If not, we must rewrite it. So we recognize 1/2 is a coefficient. Inside or outside the integral sign makes no difference. It remains. You just have the same situation here, natural log. Over here we had 2. Now we have 1/2. So 1/2 natural log of absolute value of x plus a constant. Pretty straightforward. When we differentiate it, we did them term by term, and integration, we're going to do the same thing here. So the first one, the exponent is 4, add 1 becomes 5. So this becomes 2 over 5 x to the power of 5. Add 1 to the exponent, you get 4. 3 over 4 x to the power of 4. Add 1 to the exponent, you get 3. So negative 7/3 x cubed. Now this one, you should know when we have x and no exponent, that means the exponent is 1. Okay. So you add 1 to the exponent and you divide by it, you get 1/2 x squared, and negative 5 is minus 5x and a constant. So you add the constant at the end. You don't have to add the constant at each step. What about the integral of x minus 5 quantity squared dx? You raise this to the power according to a minus b quantity squared, which is a squared minus 2ab plus b squared. I hope everybody remembers that. So square this one 2 times this times that one minus 10x, and this one is 25. And now let's do it one by one. So first you do the algebra. You make it ready for the power rule. The first one, you add 1 to 2, you get 3, so it's 1/3 x cubed. This one, again, I'm going to put the exponent as 1. That means add 1 to it, you get 2. You get minus 10 halves x squared minus 5x squared plus 25x and a constant. And we're done. It's that simple. So ultimately, we used the power rule in this page. And now we want to integrate this expression. You may remember it when we did the differentiation. The very first step was algebra also. We're going to cut this into 3 fractions. This is 1, which makes it 1. This is minus 7 over x. This is 2 over x squared. So you make up 3 fractions, everybody. 1, second, third fractions. And we are going to integrate term by term. To make sure we understand what's going on, we are going to rewrite the second one as minus 7 times 1 over x, and this one as 2x to the power of minus 2. So this is very straightforward. 1, because we have dx, the independent variable is x, is simply x. Minus 7. Now 1 over x is a natural log, so minus 7 ln of absolute value of x. Now this one, I want to work on this one. 2 over negative 2 plus 1, x to the power of negative 2 plus 1. That I hope you recognize as 2 over negative 1 or minus 2, x to the power of negative 1 or minus 2 over x, and a constant. Very straightforward, everybody. All right. First and foremost, pay attention to the fact that you're dealing with dt, and therefore your independent variable is t. And so when you integrate 1, you get t. Cosine, the derivative is negative sign, but the integral is positive sign. So according to this, plus sine t and a constant. So very straightforward, everybody. What about this one? Again, cube root of x, change it. That's the first step. Change it such that it becomes ready for the power rule. So this would be 1 over 1/3 plus 1, x to the power of 1/3 plus 1. Again, in this format, remember, even in the case of a differentiation, we don't do anything, we change it first. Minus, again, the derivative of sine is cosine, but the integral is negative cosine. So let's write minus cosine and a constant. Again, the integral of sine is negative cosine, okay? And as you know, this is 4/3, this is 3/4, and x to the power of 4/3 is the same as cube root of x to the power. So you just rewrite it in this fashion and you're done. Okay, class. We're just practicing with basic integration. dp dt is 2e to the power of 3t. Find p of 0 equals 1. This is a class of problem known as the initial value problem. So we're going to discuss the concept of an initial value problem. First and foremost, any equation containing a derivative is called a differential equation, short DE. A function which satisfies the equation is called a solution to the differential equation. So everything we've been doing so far has been a differential equation because we were solving integral, right? Problem, we had a dx. So and what is an initial value problem? Initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. So what happens as a result? I'm going to show you. So I'm going to completely ignore that for now. We're going to discuss what it means in a moment. So I want to show you that the very first step is the good old integration, which means I'm going to write dp is 2e 3 to e to the power of 3t times dt. And if I integrate both sides, the left side, everybody, becomes p of t, and we're going to integrate the right side. So first, let's not pay any attention to the initial value, to this one, and just do the math. And remember, k is 3 here, and we divide by it. So the answer is 2/3 e to the power of 3t and a constant. So if we didn't have this, this would be the answer. And this is a general solution. It's a general solution. It's a family of functions, and it has infinitely many answers. Remember, the effect of c is a constant, is going up and down along the y-axis. That's the minimum. You'll be done. But what is the effect of this? P of 0 equals 1 means we have the pair 0, 1, which means I can plug in and find the value of constant. So instead of family of functions, I will get to one function. So let's replace the t with 0, p of t with 1. As you know, this is 0. E to the power of 0 is 1. So 2/3 plus what number is 1? 1/3. Replace it, and you get one function as the answer. This is called a particular solution. One solution, everybody. Let's get another example to make some sense out of it. And again, this is what makes it an initial value. And for now, we're going to ignore that. Just ignore it. When you solve an initial value problem, first ignore the pair. This is pair 1 comma 5. So dy is the right side times dx. And when you integrate, you get y equals the integral of the right side. That's what we are going to integrate. And so we don't have anything to worry about 1 over x because we know the answer. We're going to change square root of x to x to the power 1/2 and bring it up to get it ready for the power rule. So this one is fine. This one is not. We changed it. It's ready for the power rule. So this is the natural log. This one, using the power rule, 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. So 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. That is very straightforward, everyone. Now, this one doesn't change. What happens to this one? Negative 1/2 and 1 is 1/2. So this must be 2. And x to the power 1/2 is square root of x. So again, this is a general solution. And we would be done if it wasn't an initial value problem, meaning if we didn't have the pair. What pair? 1 comma 5. Therefore, we are going to plug in and figure it out. Let's plug in. Replace the x with 1. Replace the y with 5. As you know, ln1 is 0. This is 1. So 2 plus what number is 5? 3. Plug it in. And now this is one solution or particular solution. Okay. Very straightforward, everybody. So the effect of one pair is to go from a family of functions to one function. Let's do another one. We want to find capital F of x where f of 2 is given as 1 and capital F prime is 3x squared plus 3x plus 7. So please understand capital F prime, that means df dx. So you're going to integrate to get to capital F of x. You're going to integrate this, of course, times dx. Okay. And for now, we're going to ignore that. And this is a very simple power rule. X cubed plus 3 halves x, 3 halves x squared plus 7x plus a constant. Again, a general solution. We have a pair f of 2 equals 1. That means we have a pair 2 comma 1. Replace the x with 2, y with 1, observe. I hope you see what you get. So just to make sure we understand how we arrive at this, when we plug in class, this is 4, this is 8, right? So 8, 3 halves times 4, 12 over 2 is 6, 7 times 2 is 14. And as you can see, we get 28 here. 28 plus what number is 1? Negative 27. Replace the C. And so what you have here is a general solution. What you have here is a particular solution. So that's the idea behind the initial value problem. Very straightforward, everyone. The integral of x plus 1 over square root of x dx. The format has to be changed such that it becomes ready for using the power rule. So first of all, we cut it into two fractions such that the denominator is x to the power of 1/2. Denominator is x to the power of 1/2. This is 1. X over x to the power of 1/2. This is another. As you know, the exponent is 1 in the numerator. So for this one, you have x to the power of 1 minus 1/2, which is x to the power of positive 1/2. The second one, x to the power of negative 1/2. So what you're looking at is elementary algebra. We should have no problem with that so far. Now we are ready to use the power rule, everybody. Let's do that. In this case, 1 over 1/2 plus 1, x to the power of 1/2 plus 1. In this case, 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. And now we add a constant, and believe it or not, so that's x to the power of 1/2 plus 1 over 1/2 plus 1. This one, x to the power of negative 1/2. So x to the power of negative 1/2 plus 1 and negative 1/2 plus 1. Divide by negative 1/2 plus 1 and a constant. So it really can't get any easier than that. And believe it or not, this is the only calculus step, and all we have to do now is simplify. In other words, let me just put as be done. Done with calculus. Now let's do algebra again. So the point being, I'm going to count the number of algebras after that. So 1/2 and 1 is 3 halves. So x to the power of 3 halves over 3 halves. Negative 1 and negative 1/2 and 1 is positive 1/2. So let's replace it. Now this one, 1 over 3 halves gives you 2/3. 1 over 1/2 gives you 2. So we have, see, we change this to x to the power of 1/2 because into two pieces, okay, to get it ready for this one. So 1, 2, 3, 4, 5 steps of algebra and only 1 step of calculus. And that's really important to understand. There is not a lot of calculus involved, everybody. Not a lot of calculus involved. That's the idea. Example 7. A sample of cesium-137 with an initial mass of 79 milligrams decays T years later at a rate of negative 1.8249 e to the power of negative 0.0231 T milligrams per year. Find the mass of the sample after 23 years. Round your answer to 1 decimal. Let's just look at this example. What the question is, what needs to be done. The moment you hear rate in calculus, it refers to differentiation. So if we want to find the mass, if the mass is represented by m over t, let m over t represent the mass of cesium-137 after t years. Cesium-137 is a radioactive substance. Then what is given here is dm dt, m prime of t, dm dt. So dm dt is this. What is this one? What is initial mean? M at t equals 0. That's the meaning of the initial value. So m of 0 is 79. So you go through the process and you find the formula for m of t. After you find the formula for m of t, all you have to do, replace the t with 23. You have the answer to the question. So to recap, let m of t represent the mass after t years. Its derivative, dm dt, is what is given here. The initial value refers to m of 0, and we want to find m of 23. So how do we find m of t? We put the dt next to this and we integrate this. If we integrate this times dt, that would be m of t, everybody. So we are going to find m of t. So the integral of e to the power of kx is itself divided by k. So it's e to something to the power of whatever. So the answer is itself. This number doesn't go away. This is a coefficient remains. You can even take it outside the integral sign. So this number remains. The answer is itself. And you divide by the coefficient of t. Over here, we divide by the coefficient of x, which is k. So this number divided by this number, meaning negative 1.8249, divided by negative 0.0231, e to the power of the same thing, and a constant. You put this into a calculator, it gives you 79. Now, if the initial value is 79, we plug in m of 0 is 79. We plug in, which means we're going to get 79 e to the power of 0, right? Any number times 0 is 0, plus a constant is 79, and e to the power of 0 is 1. 79 plus what number? Is 79. 0. The constant becomes 0. It's that simple, everybody. Therefore, the general solution, which is this one, let me just erase my word. The general solution, which is this one, gives rise to a particular solution, which is this one without the constant, because we found the constant to be 0. That's what we were looking for. Now we are ready to plug in 23 and find M of 23. So into this formula, replace the T with 23, which means M of 23 is the same thing. Replace the T with 23, multiply these two, raise the 8 to that power, multiply by 79. In other words, put it into a calculator. You always use many decimals, and then, so in every intermediate step, you use many, many, many decimals. The last one, you can round it accordingly. They're asking for one decimal, 46.4 next to this 3, so it remains unchanged, 46.4 milligrams, which means after 23 years, according to this formula that is given, 79 milligram decays to 46.4. It's a radioactive substance, everybody.